All right, so 6x squared plus 7 equals 23x. And the directions will say solve using the quadratic formula. So I'll give you the quadratic formula.
Change the standard form.
And there's quadratic formula. So yes, you have to put in standard form
Subtract everything
and
on
put
the
in descending order. So what would you write it as?
23x, no, 6x squared plus 7.
No,
No,
minus
minus,
23x
yeah, that.
plus 7 equals
Okay.
12.
There you go.
And then you got to determine what A, B, and C are.
At that point, A is 6.
A, B, and C. So A is
6,
6, B is
negative 23.
negative 23, and C is 7. And it's just a matter of you putting those three numbers into the formula. And so you would say x equal, remember this, when you read this as the opposite of B. So what's B in this case? Negative 23.
Positive 23.
So the opposite of negative 23 is a positive 23. Plus or minus the square root of. And remember when we did this last class period, the b squared minus 4ac is called the discriminant. You're not going to use it in here, you will next semester. And we put the numbers in parentheses. So we said b, which is negative 23 squared, minus 4 times a is 6, times c, which is 7. All divided by 2 times a, and a is 6.
So it's 12.
Okay? All right. Okay, now, what's the next thing you would deal with?
Breaking down everything on square root.
Okay, so the discriminant, you would use your calculator. On your calculator, now remember, if on your calculator you say negative 23 squared, it's going to give you a negative number.
Right.
But you got to remember that b squared is always going to be what kind of number?
Negative.
Positive or 0. It's never going to be negative because you're squaring a real number. A negative times a negative is a positive. A positive times a positive is a positive. 0 times 0 is 0. So in your calculator, what's a negative 23 times a negative 23? What is it? 569? 529? Okay, 23 plus or minus 529. A negative 4 times a positive 6 times a positive 7 is what?
Negative 168.
Negative 168?
6 times 7. So negative 4 times 4.
Negative 4 times 6 times 7.
Okay. Negative 4,
Divided by 12.
2. Negative 168.
Now what are you going to do?
Subtract those two numbers.
Is a 23 plus or minus the square root of
329 minus.
361.
361?
Wait a minute. No, 320.
361.
360.
Divided by 12.
Yeah, that.
Okay. Morgan, did you turn in all the worksheets that you did today? Okay, now what you want to do first is see if 361 is a perfect square. So take the square root of 361
19.
and see if it's a whole number.
It is.
Okay, so it is a perfect square. So this is the first thing you want to do. If you got a decimal, then it would mean that it would be irrational. So this is rational. So since the square root of 361 is just 19, your solutions are rational.
23.
Hold on,
19.
David. Your solutions are rational. Okay? So if they're rational, you have to rewrite your answers. You have to write your answers a certain way. Okay, so then you get 23 plus or minus 19 divided by 12. All right, so see there's no square root anymore, right? So it's not irrational. If there was a square root left, it would be irrational. Since all of these are integers, it's rational. So then you're going to break it apart. You're going to say 23 plus 19 divided by 12, and then 23 minus 19 divided by 12. Okay, what's 23 plus 19?
42
And 42 divided by 12.
Three and a half.
over 2.
Yeah, go ahead and leave it as a fraction. So what is it? 7 over 2. Okay. And over here, 23 minus 19 is 4. And what's 4/12? That's 1/3. So you're in the blank, you would say your answers would be 7/2, comma, 1/3. Now don't put that in parentheses. When you put in parentheses, it represents an ordered pair.
Would
So you could
care
put
to
a
have
brace.
X equals in front of them?
You could leave it like this with nothing, or you could say x equals 7/2, comma, x equal 1/3. Or you could use a set notation, you know, the braces, but not parentheses. Set brace for set notation. Either one of those ways will be fine. Probably the one in my math lab, they're gonna probably want the one that says x equal.
Can you just put the X equals one time and then put the comma between the two?
I'm not sure what my math lab would tell you.
Maybe on 12, maybe on the worksheets that you're gonna be grading.
Huh?
On the worksheets that you're.
That's
gonna be
fine. That's fine. I don't know what my math lab's going to want. Okay. All right. So you know what to do when it says when it's rational. Now that's on your test Tuesday. Now, what if you had this one? So you had 3 worksheets on this section. The first worksheet was where you had rational solutions, look like this. The second worksheet was where it was irrational. And the third worksheet was where it was complex numbers. That's where you saw that I. Okay? So let's look at this one. So the number 2 is going to be on your final, possibly. It's not going to be your test because your test has this kind where it's rational. All right, suppose you had this one. Suppose you had 4x squared minus 2x equal 5.
Change it to standard notation by subtracting 5.
All right, and you put in descending order. So it's going to be 4x squared minus 2x minus 5 equals 0. All right, so the next thing you need to do is determine what A, B, and C are.
A.
So what's A?
4.
What's B?
-2.
And what's C?
-5.
All right. And then it's just a matter of you taking those 3 numbers and substituting into the formula. So remember, your formula is the opposite of B, plus or minus the square root of B squared, minus 4AC. All of that's being divided by 2A. All right, so X equal. Okay, so when you read it, this reads as the opposite of B. Well, what's B in this case?
-2, so 2 is the.
The opposite of that would be a 2. Plus or minus the square root of. In parentheses, notice when I do the discriminant part, I put all those numbers in parentheses. So -2, I am squaring it,
Square,
minus 4 times A in parentheses,
which is 4.
times C in parentheses,
-5,
-5. All divided by 2 times A, which is 4. All right, and then the next step is to simplify your radicand. -2 squared is 4. That's easy. You do not need a calculator for that. Plus or minus 4. Now, a -4 times a positive 4 times a -5.
4 times 5 is
80?
-20.
Positive 80? All over 8, right?
Yep.
So we got 2 plus or minus the square root of 84 divided by 8. So that's where I'm at. Now you got to ask yourself, is 84 a perfect square? No.
Sure is.
So, and if you didn't know that, I mean, hopefully you did, because what number times its what whole number times itself is 84? There isn't any. But if you did not know that, then use your calculator. Check and see what the square root of 84 is. It turned out to be a decimal. It turns out to be a decimal if you did it. There's no repetition, but it doesn't terminate. It keeps on going. But there's no repetition. Since there's no repetition, this is an irrational number. So you see how I have a square root left?
Mm-hmm.
And that radicand is not a perfect square? That's irrational. So there's no way there's no way that the square root goes away because 84 is not a perfect square. So it's an irrational number. If it's irrational, the direction is going to say this, though. The direction is going to say simplify the radical, or simplify. So you got to ask yourself, well, is there a perfect square that goes into 84? You had to turn that in today. 4 is a perfect square that goes into 84.
Yeah.
Okay?
Yeah.
So what you do is off to the side, you figure out what the square root of 84 is. So there's a square root of 4 times 21. And so it's the square root of 4.
2.
So 2 square root of 21. So that's what you put here.
Right.
Now, before I go on, you remember in the previous problem, we split it apart?
Mm-hmm.
Okay. Now, you can do that here, except it's not going to be rational. On my math lab, when you do my math lab, they're going to want the solutions separated by commas. So my math lab, you would split it apart. You'd say 2 plus the square root of 84 over what? 8. And then 2 minus the square root of 84 over 8. Okay?
So you will leave it like that on my math lab?
No. Nope.
Okay.
Nope. We're getting to that point. Hold on, David.
Okay.
Hold on. You guys simplify the square root of 84, though. This is what we're doing right now. Okay?
Mhm.
All right. So then you're going to say, I'm going to put it right here. So this is going to be 2 plus or minus 2 square root of 21 over 8. Y'all agree?
Mm-hmm.
Okay. Now, let's talk about this for a moment. I'm circling these numbers here. I'm circling all the numbers that's in the numerator except the radical. Do those 3 things I have circled have anything in common besides 1? A 2. So you say 2 into 2 is 1, 2 into 2 is 1, 2 to 8 is 4. And then you would say 1 plus or minus the square root of 21 over what?
Oh,
4.
4. That's what you would give me.
So you would have to put that one though?
This one?
Yeah.
Yes.
Okay.
What would you put there?
Mhm.
No, you got to have something there because if you put nothing there, that's understood to be a 0.
Yeah, you're right.
Okay? It's understood to be a 0. 2 divided by 2 is 1. You have to put that 1 there. Now, do I need that 1 in front of the square root of 21? No. That's understood to be a 1. Okay? Now, this is what you would give me, though. My math lab, you see how I split it apart? Don't write like this, though, in the answer for math lab. This is what they want. You would say, my math lab, you would say 1 plus the square root of 21 over 4, and then 1 minus the square root of 21 over 4, and then you'd separate it by comma. Okay?
Got a question for you. When I was checking my stuff, I came up with where it was like a 1 over 4 plus then the other part over 4, where like it actually separated the 1 and the right and the
What's your question?
is that acceptable as well?
Okay, so what he's saying is this. So you see how it's written as 1 fraction? He's wanting to know, can I write it as 2 fractions? So in other words, can you say 1 divided by 4 plus the square root of 21 over 4? That's what he's asking. And then over here, 1 over 4 minus square root of 21 over 4. Those are all acceptable ways of writing the answer. Okay, is that clear? Over here, you see how we have that plus or minus right here? Guys, see it? So another acceptable way of writing this is this way. You could say 1/4 plus or minus the square root of 21 over 4. Those are all, see right here? 1 divided by 4 plus or minus the square root of 21 over 4. All right? Those are all acceptable ways of writing the answer. But in my math lab, they're going to want the solution separated by a comma. So either one of these on my math lab should suffice. Okay? All right, it's not that difficult. Not that difficult. You just got to remember that you can't leave your answer as square root of 84 that you got to simplify the square root of 84, so you got to remember what you just turned in today. What perfect square goes into 84? All right? Okay, let's look at this one. So this, number 2, should help you with worksheet B, the B part for 11.2. Number 3, suppose you had 3x squared plus 4x plus 5 equals 0. Is it in standard form?
Yes.
What's A?
3,
What's B?
4,
And what's C?
5,
All right, so x equal the opposite of B,
-4,
-4, plus or minus B. Put that in parentheses. What do I do to that B?
squared,
Squared. Minus 4 times A
which is 3,
times C,
5,
all divided by 2 times
A,
3.
3.
Okay? All right, now simplify the radicand.
Let's see, 4 times 4,
I've got -4
16,
plus or minus 16. Now, what's a -4 times 3 times 15 in your calculator?
Oh,
Negative 60.
44.
Minus 60, right?
Oh, yeah, 60.
All divided by 6. Now, what's 16 minus 60?
Negative
-45,
44.
44, okay.
All right, so that's where I'm at. Okay?
Ooh, that's high.
All right, now remember, one of the things that you had to turn in today was simplify the square root of -44. How do you simplify the square root of -44? Now, don't say you don't know because you turned that in today.
Imaginary number.
Okay, that's that square root of a negative. So in other words, you know that this right here means the same thing as saying square root of -1 times square root of 44, right? And the square root of -1 by definition is I. And then what perfect square goes into 44? 4. So square root of 4 times 11. And what's the square root of 4?
2.
2. But how do we write this whole expression though?
2i squared root of
2i square root of 11. So that's what you had to do today. That's what you had to turn in. And that goes here. Okay? Now, number 1 that we did were rational solutions. Number 2 that we did were irrational. Number 3, remember, a real number is rational or irrational. Be careful. Don't say that first of all, it cannot be rational for 2 reasons. It can't be rational because I have a square root of 11 there. All right, rational number. Remember, a rational number is where it is a number where you can write as a fraction. An integer divided by an integer. Is a square root of 11 an integer? No. Secondly, if you put the square root of 11 in your calculator, we also talked about the fact that a rational number can be written as either a terminating decimal or a decimal that does not terminate but repeats. Digits repeat. The square root of 11 doesn't terminate, but nothing repeats. So it's irrational. But this is not an irrational number, because an irrational number has to be a real number. Something that you dealt with since birth. That's a complex number. All right, so that's worksheet C. That's worksheet C. So that's where you get that I. So, you get to that point, you get most of your points. But you leave it like this, you don't get all of your points. You may lose a
Yes.
point.
Split it apart.
Nope.
No.
Circle these right here and ask yourself.
Oh.
Now, I wouldn't circle it because it kind of messes things up, but in your mind, you would be circling those numbers and ask yourself, is what I have circled, besides the number 1, do they have anything else in common?
Obviously 2.
A 2. So then I would simplify using that idea. Now there are guys, there are multiple ways of dealing with this. So I'm going to do it in different ways and in terms of how you can write the answer. So one way to write the answer is to leave it as one fraction, like I have. Something in the numerator divided by something in the denominator. If you do though, circle in your mind, circle those numbers and ask yourself, can I reduce? Yes, you can. What's negative 4 divided by 2?
2,
Plus or minus, what's 2 divided by 2?
1,
But do I need to put that 1 there?
no.
I'm just going to write as I square root of 11 over
3,
3. So that would be an acceptable answer. Now here's another acceptable answer. Let's go back here. Remember how he said, can I split into 2 fractions? Okay? Okay, listen carefully. So do y'all agree that this is the same thing as, say, negative 4 divided by 6 plus or minus 2I square root of 11 divided by 6, right?
Yes.
But you got to reduce. So what's negative 4 6?
negative 2/3,
Plus or minus, what's 2 6 reduced?
1/3,
1/3. So you agree that's I square root of 11 over 3? That would be another acceptable answer. Okay? Now, you can also split it apart. Multiple ways of doing this, so listen. Each part that have circles is an acceptable answer. So another acceptable answer, and that would be the one from my math lab, would be negative 2 plus or minus negative 2 plus I square root of 11 over 3, comma, and what's the other?
negative 2 minus I square root of 11 over 3.
Yeah, so that's another acceptable answer. Another acceptable answer is using those 2 fractions here, but separated by commas.
Right.
So you'd say negative 2/3 plus I square root of 11 over 3, comma, negative 2/3 minus I square root of 11 over 3. So these 4 things would be acceptable as long as it's simplified and reduced. All right. All right, let's look at number 4. Number 4. All right, so let's suppose you had 9x squared minus 6x plus 1 equals 0. All right, is it in the standard form?
Yes.
Okay, what's A?
9,
What's B?
negative 6,
Okay, negative 6. Make sure you keep the correct signs. And what's C?
1,
All right. So we plug into the formula. So x equals the opposite of B,
which is 6,
which would be the opposite of negative 6 is 6, plus or minus the square root of. All right, so put all those numbers in parentheses and the discriminant.
negative 6 in parentheses,
Squared
power
minus 4 times A,
9 times 1,
all over
9 plus 2,
9 times 2.
or times 2.
All right, any questions at this point? Okay, so then I get 6 plus or minus the square root of
Negative 6 times negative 6 is positive 36.
minus,
Minus 9 times negative 4, which is negative 36.
what's 36 minus 36? And what's the square root of 0?
0.
So basically, you see this looks like 6 plus or minus 0 over 18, right?
That we call double root.
Right. So that 6 plus or minus 0, that 6 plus 0, 6 minus 0 is still going to be what number? 6. So this is just 6/18.
Which is 1/3.
Now that's rational because the square root went away. So that's a rational number. So you only end up with one distinct solution. Now if you go back to the video, you'll notice that, and this will be important next semester, that this is really called a double root. So it's a solution that occurs how many times? Twice.
You gotta put-
6 plus 0, 18, and 6 minus 0, 18.
you gotta
same thing.
simplify to 1/3.
Right, 1/3. So that'll be your answer. Okay, so that'll be worksheet A in this case, because it's rational.
There was one of them in the stuff we turned in today.
What's that again?
There was one of them on the stuff we turned in today.
Okay. 5, 3x squared plus 7x minus 2 equals 0. Which is in standard form, is it?
Yes,
Okay. What's A?
3,
B?
7.
And C. Okay, so x equal the opposite of B.
So, -7,
Plus or minus the square root of B, which is 7
7
squared.
squared.
Minus 4 times
3 times -2.
all over 2 times 3. Okay. So I get -7 plus or minus the square root of 49.
49
Now -4 times a positive 3 times a -2.
-24. No, yeah, plus 24.
Over 6. What's 49 plus 24?
Uh,
73?
3.
All right. Now, 73 is not perfect square, so you can easily determine that. No whole number times itself is 73. So it is going to be irrational. It's not a complex number because there's no I involved here. But is there a perfect square other than 1 that goes into 73?
If there is, I can't think of it.
That's your answer. Leave it like that. There's your answer. Now, again, you would ask yourself, can I simplify -7, 1, and 6?
No.
No. On my math lab, you would have to split it apart. You'd say -7 plus square root of 73 over 6, comma, -7 minus square root of 73 over 6. Now, next semester, one of the things you're going to do is you're going to estimate these in your calculator. Now, you're not going to do it here because we don't have time, and then I'm going to ask you that on the final, but next semester you're going to have to determine on the calculator, what is this approximate equal to? So what you're going to do is you're going to say -7 plus square root of 73 press equal, and then say divide by 6. -7 minus the square root of 73 plus press equal or enter, and then divide by what? 6. Okay? All right, so any questions on this? Okay, now, let's see if you remember how to do this. Solve. How would you do that?
Square root of both sides.
All right, so here you'd have to use the square root property, correct? Y'all agree? Okay. So remember, you use the square root property if it's in this form, something squared equal a number, right? And that's in that form, something squared equal a number. So then you would take the square root of both sides. So you're trying to get rid of the square. The opposite of squaring is to do what? Square rooting. Now, mistake that people make is they'll do this, but what's wrong?
Yeah, square root 49. The square root,
No, it's on the left.
What?
I have the square root of 49. What is wrong with what I've written?
Because you put your exponent in your square root.
No.
I mean, well, you just
Plus or
convert-
minus.
Oh. Yeah, that.
That's what some of you are going to do.
Yeah,
You're going to
plus or
say
minus-
that,
plus or minus
and
square root of 49.
then you will only have given me one solution. There are how many solutions here?
2.
Because it's quadratic, right?
Mhm.
That's a quadratic equation. How do you know that this is quadratic?
Square.
Because if I actually do FOIL this out, what's 2x times 2x? It's taking you a long time to figure this out. What's 2x times 2x?
4 squared.
4x squared. That's quadratic. So that's quadratic equation. This quadratic equation is written in that nice form right here, which implies I can solve it using what property? Square root property. But remember, when we did the quadratic formula, didn't you see that plus or minus square root in there?
Mm-hmm.
So what do you need right here?
Plus minus.
Plus or minus.
Equal sign.
Okay, so then the square and the square root into each other. So what's left on the left?
2x minus 3 equals plus or minus square root of 49.
Which is 7.
7.
So is this rational or irrational?
Rational.
Rational, because it's no longer a square root. Since it's rational, you split it apart.
2x
You split it
minus
apart.
3.
So 2x minus 3 equals a 7. 2x minus 3 equals a what?
Negative 7.
Negative 7. So notice I went from a quadratic equation. Make sure you understand this quadratic now. A quadratic equation. I did not use the quadratic formula. I used the square root property because it was in that form. You understand that this form here, this quadratic equation, has a different form than this quadratic equation.
Right.
This quadratic equation is in standard form. I use the quadratic formula. This quadratic equation is in this form. I use the square root property. Okay? But this quadratic equation, I went from a quadratic equation to 2 linear. So how do you solve these each linear equation?
Add 3 to both sides on both of them.
So here, 2x equal 10.
10.
So what's x?
5.
Here, 2x equal negative 4. So what's x? Taking a long time to tell me what x
2.
is. Negative 2. So there's your two solutions. Notice those are rational numbers, rational solutions. All right, and then finally, suppose you had this.
Still square root property.
All right, what kind of equation is this?
It's,
Quadratic. You're not going to use a I'm sorry, you're not going to use the quadratic formula here because it's not written in standard form. But it's written in that form to where you can use the square root property.
but because you're going to have the square root of a negative 64, it's going to have an I.
That's right. So when I take the square root of both sides, what am I missing though?
Plus or minus.
Plus or minus. And I'm taking the square root of a negative number, so that's where that imaginary number comes into play. So on the left side, what expression is left?
5x minus 3
Equal?
plus or minus square root of negative 64.
What's the square root of 64? 8. So what does this become?
8i.
8i. Okay? Now here's how you write the answer. You remember when we did, let's look at this irrational number. Remember when we did this irrational number, we said this was acceptable? Okay? When we did this complex number with the I, this was acceptable, one fraction. See how it looks? Negative 2 plus or minus the radical with the I. Negative 7 plus or minus the radical. You want to write that? You want to write it like this. So first thing I'm going to do is what?
5x. You gotta
Add 3 to both sides. So do y'all agree that's 5x equals 3 plus or minus 8i? And then how to get x by itself? Divide by 5. So when I divide by 5, do y'all agree that x is 3 plus or minus 8i over 5? Can I reduce anything? Can I reduce the 3, 8 into 5?
No.
No. So that's acceptable.
Yeah.
If you want to split it apart, you can.
One of each.
You would say 3 plus 8i over 5. 3 minus 8i over 5. That would be another acceptable answer. You can split it into 2 fractions if you want to. Now this is the one that my math lab will want. You have to separate those by commas. Or you could say 3 what?
3 over 5.
Fifths plus or minus 8i over 5. Right? You can even split this apart. Okay?
3 fifths plus 8i over 5. 3 fifths
Minus
8i over 5.
8i over 5, right. Okay, so any questions? All right, so remember the one, I forgot on your study guide how many questions there were from that section, but this is section 11.1. I think there's just one question maybe. Okay. All right, now So that was a quick review on stuff we've done the last class period. Now worksheet 11.1. I'm sorry, 11.2. 11. This was due today. 11.2 B and C.
29th.
The 29th? Okay. But 11.2 Part A was due today. All right. Okay.
So about 4 of my math labs doing.
There's some math labs being due as well. Okay. So, this is new section. Not difficult. If you remember how to simplify radicals, you're fine. Okay, this is section 10.4. 10.4. Okay, so let's look at number 6. Here's what we have at number 6. You have 4 square root of 32 minus square root of 18 plus 2 square root of 128.
Jeez.
So in your final, they usually have one question from this section.
When you gonna get wrong?
Is what that? No, 'cause I think if you find common ground, I think it'll be a little easier. 2 square root 128.
That's
Okay.
2 square root of 128. Okay, so you got to use information you've dealt with already. If I cover these two things here, what do you think you may want to do to this?
4 times square root of 32.
Simplify the square root of the square root of 32. What perfect square goes into 32? That's the idea.
4.
If I cover these up, how do you simplify this? What perfect square goes into 18, right? Okay. So here you're adding and subtracting radicals. That's what you're doing. But you got to use information you've learned. So let's deal with the square root of 32. What perfect square goes into 32?
4.
Use the largest. Always use the largest. Always best. Now you can use 4.
16.
16. The largest makes things a lot easier for you. So what I would then do is this. I would say, well, that's going to be 4 square root of 16 times what? Times 2. See, if you use 4, you'd have to say 4 times 8, but then you can simplify the square root of 8.
Yeah.
So you're putting in more steps for yourself. Minus. All right, now let's talk about 18. What's the largest perfect square that goes in 18? 9. So square root of 9 times 2. Okay? Now 128. Use your calculator to help you. All right, now listen carefully to this. You see how these two right here, I'm going to be left with the square root of 2? So you ask yourself, all right, I'm left with the 2 under the radical, so maybe I'm going to be left with the 2 under this radical. So what's 128 divided by 2?
50.
And 64 is a what? Perfect square. So this will be plus 2 square root of 64 times 2. So that's where I'm at. Okay? So the first thing you're going to do is simplify each of those radicals. Nothing new. You had to turn that in today. Who said, huh?
He's talking about simplifying the radical.
Oh. Yeah.
Okay. I was like, girlfriend did not turn in her homework today.
No, I did.
Yeah, I was looking at that table right here. The girl with the hot flashes.
Yeah, I just said it was not hot flash, girl.
Okay, square root of 16 is what?
4.
4. But that 4 has to be multiplied by
The other one.
this 4. So do y'all agree that this is 16 square root of 2?
Yes.
I kind of skipped that step, but in my mind, I'm circling the square root of 16. Square root of 16 is 4, but you're saying 4 times what? 4, which is 16. This thing I have circled, the square root of 9 is what?
3.
So this would be minus what?
3.
Very good. Square root of 64 that I'm circling is
8.
8, but that 8 has to be multiplied by this 2, so that's what?
16
Square root of 2. All right, so that's where I'm at. One more step when you're done.
Add all of the coefficients.
All of the all of these radicals have the same radicand and the same index. Okay, what are the indices? Do you remember what I mean by index?
Square.
Square, 2. So the indices are 2, right? Square root, 2. The radicands are all what?
2.
2s. So that means I can combine them.
Mhm.
It's kind of like saying 16x minus 3x plus 16x. See that?
Mhm.
But it's 16 square root of 2
Right.
minus 3 square root of 2 is what?
13 square root.
13
of 2
square root of 2. 13 square root of 2 plus a 16 square root of 2 is what?
is 29 square root of 2.
So how many square root of 2's do I have?
29,
29
square
of
root 2.
And there's your answer. That's all you're doing.
It starts off like that, but
Yeah.
where do we go from there?
It starts off looking like something.
What do you mean where we go from there?
I know there's more that's gonna make it seem like it's blowing.
Yeah, you're about to get some variables in those things, girl.
Oh,
great.
God,
More
no.
letters than numbers, let's go.
Oh, God, no.
Thank God he's not here because here's a little spill.
It's going to start looking like something Sheldon Cooper would write on a chalkboard.
Right.
All right. Oops, did not mean to be number 7. This is going to be number.
But wait, there's more.
All right, number 8. All right. You have. Oh, okay, I need to do one with square roots. So this is a
Not 8.
cube root. No, not 8. Let's do 10. 10 is square roots. You only have to be able to do stuff with the square roots. So 10, you have the square root of 4x to the 7th plus 9x squared square root of x cubed
Jeez.
minus 5x square root of x to the 5th. You have everything you turned in today or last class period is needed for this, and you can do it. You remember how to deal with
So
this?
There's only going to be one on the final?
Was one problem from, they usually have one problem from this section. Come on, but you dealt with this kind before. What is this right here? How do you deal with this?
4 times. See,
No,
square root of 4.
Square root of 4 is
2.
2. So basically, this is what you said, guys. You said this. You said, I'm just looking at this one for right now. You said, well, that's going to be the square root of 4 times the square root of x to the 7th, right?
That's right.
The square root of 4 is what, though? 2.
So 2 square root.
But then, depending on if you use a shortcut or not, you said 2 goes into 7 3 times with a remainder of
1.
1. Now, if you use that shortcut on that worksheet you do today, what will be this answer? Will be 2 what right here? 2x to the 3rd square root of x. That's a shortcut. The way, if you look at the key that I gave you for this worksheet you turned in, this is the way I did it. I wrote this back as, see this is radical notation? I wrote it back as an exponent. So that's x to the 7 divided by what? 2. What's 7 divided by 2 is a mixed number?
3.5.
All right. And so do y'all agree that's 2x cubed x to the 1/2?
Yikes.
Yes or no?
Yes.
Makes
Okay.
sense.
And then this right here, x to the 1/2 is what? Radical.
X, square root of x.
Square root of x. So that's 2x cubed square root of x.
Put me in.
So on your worksheet today, you had something like this where you had square root of 4x to the 7th. You were to give me 2x cubed square root of x. That's what you were to give me. Whether you did the shortcut or you did the long way. This is what you had to give me. Let's do this one. How do you simplify the square root of x cubed is the next thing we got to deal with. Okay, so she's doing a shortcut. 2 goes into 3 one time with a remainder of what? 1. So she said x square root of x. That is true. If we do the long way, this is what you did. You said plus 9x squared times x to the 3 divided by what? 2. 3 divided by 2 is what mixed number?
1.5.
9x squared times x to the 1 and 1/2. Then at x to the 1 and 1/2 is really this that I'm about to write. 9x squared times x
Square root of
times x to the 1/2. Okay?
which is a square root of x.
All right. Now, listen carefully. What is this x squared times x right here?
X to the third.
X to the third, so that's plus 9x cubed. And what's this right here as a radical?
Square root of x.
So I'm just rewrite it. 9x cubed, square root of x. All right. Now let's go to the last one. Let's do it the long way. Well, first of all, what would be the shortcut? If I cover the 5x and I just ask you, what is the square root of x to the 5th simplified? X squared, square root of x. That's correct. You'd say 2 goes into 5 2 times, so that's your x squared. The remainder what? 1. Since we're dealing with square roots, it's always going to be a remainder of what? 1. It will always be a remainder 1. But the long way would be, okay, this is what you would say. You'd say 5x times x to what power? 5 divided by
5/2.
2 minus 5x times x to what mixed number?
2.5.
Minus 5x times x squared times x to the 1/2. Now what's x times x squared?
X to the third.
So that's 5x cubed. And then this right here is what radical?
Square root of x.
Okay. So it's a long process,
Everything.
but I did it the long way. The short way, if you can do the short way without any difficulty, you don't have to do all these steps.
Right now,
But-
everything's the same.
But you got to ask yourself, are there any of these that I can combine?
Yes.
All three of them.
All 3 of them. I can combine all 3 of them. Now let me say this. Before I do that, let me just say this. And this is going to be important. Here, when we did this, we said I can combine all these because when I look at the radical, they all have the same index, square root, square root, square root. They all have the same index of 2.
Right.
And the radicands were the same, right?
Right.
Okay. And the radicands are the same. So then I can combine them. But what if I had this? Four x squared root 2 plus 6 square root of 2 plus 7 square root of 2. Can I combine all of those?
No.
No,
Just a
very
second.
good. You might say, well, you just said,
just a
hold on,
second.
David. Hold on. So you might say, well, you just said that as long as all of them have the same index and the same radicand, I can combine them. But what's the issue?
Yes.
No,
It has
the
a
x.
variable.
Okay, the x.
The X is always the issue.
X marks the spot.
I should get points for that. That was awesome.
All right. So this term has an x in it, the others don't. So it's kind of like saying 3x plus 2x is what?
5x.
5x. So 3x plus 2x I can combine, right?
Right.
3x plus 2 I cannot combine. They're not like terms. All right, so that's the idea. So this, I can combine only these two.
13.
So it'll be 4x squared root of 2 plus what, 13 squared root of 2?
Square root of 2.
That's all you can do. So now go back over here. Why are all of these like terms?
Because of the
First of all,
yeah.
the index and the radicands are the same, right?
Yes.
Right.
Okay, so that's so far we're so good. But the variable x cubed, does x cubed appear in all of them?
All three of them.
Yes. If this was x squared,
Then no.
then I can only combine these two, right?
Right.
All right. So what is 2 of these plus 9 of these minus 5 of these?
11 minus 36x to the third.
Is
square
it
root
6 or
x.
5? So 9, 10, 11. 11
11.
minus 5 is
6.
6? Okay. So the answer is what, 6?
6x to the third, square root of x.
And that's it. Okay? All right, let's look at another one. Suppose we had this. As long as you remember stuff from a previous lesson, you should be okay. Let's look at 26. So think about 26. It's a square root. All right, 26. You have the square root of 4x to the 7th, y to the 5th. Remember, you had to turn this in today.
Mm-hmm.
This idea right here. Plus 9x squared times the square root of x cubed y to the 5th minus 5x y times the square root of x to the 5th y cubed. All right, so try and work ahead. So that's square root of 4x to the 7th, y to the 5th.
First thing you guys.
Hold on, David. Plus 9x squared. Oh, thank God I don't have any nightmares with the name David. 9x squared times the square root of x cubed, y to the 5th.
I think you need to get a king of brother named David.
Oh, I don't think so.
And you call her King David all the I don't even know if that's okay on a wrong level.
Minus 5xy times the square root of x to the 5th y cubed. X to the 5th y cubed. Okay, so see how far you can get. I'll give you about 5 minutes. Come up with an answer. 5 minutes. Put on the light. Let me know if you wrote it down.
I haven't read it down. I'm still
You
working.
should still be able to see it, though. You can see it.
Nope. I can barely see with the light off, much less on.
Hurry up, David.
Wow.
Alright. Square root 4, 2 goes into
Okay, so minus 5xy. 2 goes into 5.
x squared.
2 times that's x squared. Square root of
x.
X. 2 goes into 3.
1 times over y.
Just y.
And square root of y.
Square root of y. All right. And then over here, that's just 2x cubed y squared, square root of xy. Now here, what's x squared times x?
X cubed.
So that's 9x cubed y squared, square root of xy, minus, and then what is x times x squared?
X cubed. Y squared.
And then what is y times y?
Y squared.
Square root
Square
of
root of xy.
xy. So that's where I'm at. So notice I did the shortcut here. I didn't do the long way. The long way would have given me more steps. But what do you notice about all those terms?
They're now like terms.
They're all alike. So it's 2 of these plus 9 of these.
11,
And what's 11? Subtract 5 of them.
6.
Okay. So you get 6x cubed, y squared,
Square root of xy.
square root of xy. Okay?
Looking at that was quite intimidating and almost overwhelming initially.
What's your point?
My point is, if you break it down one small section at a time, it makes it a lot easier and you don't have to hyperventilate.
Hey, your boss didn't have to do it.
And my boss didn't have to look at it. He looked at business law today and he walked away.
All right. Now,
You say that often, man. It's not always.
so on your test, on your test coming up Tuesday, you would need to solve this. So let's say you had 2x minus 1 squared equal, let's say 8. All right. What would you do on your test Tuesday?
Square root of both sides.
Square root both sides. Because right now I'm squaring. What's the opposite of squaring?
Multiply.
Oh my Lord, square rooting.
Oh.
As you do the plus and minus. And so the square and the square root undo each other. You get 2x minus 1 equal plus or minus.
Square root of 8.
And you simplify the square root of 8. What perfect square goes into 8? No, 2 is not a perfect square. 4. And the square root of 4 is 2. So that's 2x minus 1 equals plus or minus 2 square root of 2. Now, is this rational or irrational? That's irrational. So then remember how to write it. You bring the 1 over, divide by 2, and you're done. So what does 2x equal?
1 plus or minus 2.
Square root 2 over 2, and then divide everything by what? 2. And so you get x equals 1 plus or minus 2 square root of 2 all over 2. So that would be your answer. Okay? Now don't make the mistake. Here's the kind of mistake people make, guys. I'm going to rewrite this right here over. Okay, now listen carefully. This is the mistake people make, and you can be upset. You reduce these 2's like this. You can't do that. You cannot reduce the 2's like that. If you reduce the 2's, this 2 that's in the denominator has to be reduced with both terms up here. But what is this number right here?
1.
A 1. You can't simplify that. So don't make that mistake. So this is wrong.
The only other thing you could do would be 1/2 plus or minus.
Okay, right. Now you can do this, what he said. You can say 1/2 plus or minus 2 square root of 2 over what? 2. Now you can reduce only these right here. And so you get 1/2 plus or minus, what's that, square root of 2? Okay, see the difference? Okay. All right, now,
Technically, you're simplifying there, so that's it.
simplifying only this fraction. All right, now, this is what we're going to talk about the last class period, one of the things. But it's not difficult. Solve this. Square root of x plus 1 equal 6. Okay, so a while ago, listen carefully. Here, I had this quadratic equation. But it was written in that nice form to where I could use what property? Square root property. Because right now I'm squaring. The opposite of squaring is to take the square root. This is a radical equation. This is a radical equation.
Is there some way to convert that to the other way?
This is a radical equation. All right? Right now, the x is under the radical. What's this index right here? 2. So right now I'm taking the square root of the left side, right? What's the opposite of taking the square root? Squaring both sides. So watch how simple this is. Listen carefully. This is how we would write it. You square both sides. Make a connection between this and this. The square and the square root undo each other. That's what you have here. The square and the square root undo each other. So what's left?
X plus 1 equals 6 squared.
Which is 36.
Yes.
So notice I went from this radical equation to what kind of equation?
Just a
Linear. So what's x?
Subtract 1 from both sides.
So what's x?
35.
That's your answer. So we're going to look at that next class period.
Yeah.
So there is a radical equation in your final. There always has been every semester.
Will it be clearly labeled?
It'll look like this. It won't say solve this radical equation.
Why not?
Look at the outside, there's a flashlight.
It will not say, hey y'all, this is a radical equation, solve this radical equation.
That just makes
It will just say solve. But it's not difficult. You're only dealing with square roots here. If this was a cube root, you would raise both sides to what power? The third power. If this was fourth root, you'd raise both sides to what power? Fourth, and so on. It's not difficult. All right, so let's see what time it is.
About that
Okay.
time.
All right, so